Welcome students. Last class we studied about p block elements, introduction, position in the periodic table. This class we are going to see anomalous behavior of boron. What is anomalous behavior of boron is how boron differ from own group elements in certain properties. Boron group consists of boron, aluminium, gallium, indium, thallium and novium. Boron group consists of boron of atomic number 5, aluminium, gallium, indium, thallium and novium. Boron is the first element in its group. The first element is small size. On moving from left to right, atomic size decreases. On moving down the group, atomic size increases. So boron is the smallest element. So how boron or why boron differed from one group element in certain respect is due to the following property. As its first element, it's of small size and high electron density and high electronegativity. High electron density is it is small size. The distance between the nucleus and the valence electron is the distance is short, thereby the attraction of the nucleus over the valence electron, the outermost electron is high, thereby to pull the electron inwards, and by the smaller the size and the higher the electron density. The electronegativity, the phenomenon of attracting the shared pair of electron in an atom towards itself is called electronegativity. Non-availability of d electrons. So the atomic number is 5. There is no possibility of moving s, p, d, f. There is no possibility of the electron going to the d orbital. So there is no absence of d electron in boron atom. The reason for the why boron is differed from its own group element, that property is called anomalous behavior of boron. Next we are going to see in what are the properties boron differed from its own group elements. Here in this we are going to see anomalous behavior of boron, or how boron differed from the elements of its own group, the other elements of same group. Here the properties of boron is listed out. Here the properties of the other group other elements in boron group is listed out. Here the boron, the first element is non-metal, but all other elements are in metallic state. Boron is the only element present as a non-metal, but other elements in that group are metals. As it is a non-metal, it possesses high melting and boiling point. Here the melting and boiling point of other elements are lower than boron. And here boron only forming covalent compounds of covalency. The boron covalency is 4. The bonding valency is 4. Covalent bonding means the sharing up of electron. The sharing up of electron will go during the bond formation. Boron only form covalent bonding and covalent compounds. Here the other elements forming covalent and ionic compound. Covalency is sharing up of electron. Ionic is the giving or accepting or the transferring electron is called ionic bonding or ionic compound. For example, the aluminium covalency is the valency is 6. Here the boron valency is 4. Only covalent compounds, so the covalency. Only covalent, here covalent and ionic. And it exists in crystalline and amorphous form. Rendu state here both exist in crystalline form, crystal form and powdery form. Powdery form is called amorphous form. It is not existence. And here oxides and hydroxides are acidic in nature. Oxides and hydroxides of acidic in nature means when we dissolve the boron oxides and hydroxide in water, it is giving acidic solution, that is called oxides and hydroxides are acidic in nature. But here amphoteric and basic in nature. Amphoteric means neutral. Here oxides of other elements when dissolved in water, it is giving amphoteric base and also basic in nature. Basic solution, and here it is acidic solution. And here the hydrates are stable. Boron hydrate, boron BH3. For example, BH3, the hydrate means the compound formed with hydrogen is called hydrate. For example, BH3, boron. Here the hydrates are stable, and here the elements forming compounds with hydrogen are not stable, but boron hydrates are stable. Here boron, when reacts with metal, it forms metal borates, Mg3B2. For example, magnesium borate, Mg3B2, magnesium borate. Here with the metal, it from the mixture of metals form alloys. Alloys means mixture of metals. So the other group elements in boron family forming alloy when reacts with metal and not decomposes with steam. Here boron not decomposes steam, but other elements are decomposes steam. Here next one is moistened boron. The state of boron is called moistened boron. That is another state of boron. It's of low purity and black in color. That is not available, that is not possible in the case of other elements. So now again we are going to see the difference between how boron differed from one group elements, or how the properties of boron is differ from or anomaly from its own group elements or other elements of same group. Boron is a non-metal, all others are metal. Boron possesses high melting and boiling point. Here the melting and boiling point is lower than boron. Here it forms only covalent compound of valency 4. Here it forms covalent and ionic compound of valency 6. Here it exists in crystalline and amorphous form, that is not exist here. And here when we dissolve the oxides and hydroxide, it gives acidic nature, and here in the case of it gives the amphoteric and basic substance. When we dissolve the oxides and hydroxide, the solution become basic and amphoteric in nature. And next one is the hydrates of boron, the compounds of boron with hydrogen. When boron reacts with hydrogen, it forms hydrates that are very stable. Here it is unstable. And here the boron with the metal, it forms metal borates, magnesium borate. Here with the metal, it forms alloys only. Here not decomposes, not reacts with the steam, the other decomposes steam. The other form of boron is called moistened boron of low purity and black in color, the other state of boron that is not available in the case of other elements. So these are all the properties how boron differ from its own group element. This property is called anomalous behavior of boron.